So today's lesson is going to be on reading dot plots. Okay, today we're going to just look at them and analyze them, and then tomorrow we're going to actually make our own dot plots. Okay, so remember that a dot plot is basically a way of taking information and putting it together based on place value. Okay, so a lot of times we have things like this sort of survey question that you see here. Remember, survey is another one of our vocabulary words for this week, and that just means it's a question that we're asking someone. Okay, so if I'm looking here at this dot plot, I have pet ownership. So they're asking, how many pets do you own? Okay, and remember, the very important thing about dot plots is that each dot within the whole graph represents one answer. Okay, so if I'm asking people, how many pets do you own? Each person or each dot is a person. Okay, so for instance, this could be me because I have 2 pets. Okay, this could be Miss Stroba because she has 1 pet. Okay, so each dot represents a different person. Okay, so we're going to do a couple of problems together. So first we're going to look at this one. This says a group of students was asked how many blocks they walk from home to school each day. Okay, notice the title. That's exactly what the title is saying. Distances from home to school. Okay, and the label is telling me we're talking about number of blocks. The results are shown in the dot plot below. How many students were asked the question? Okay. Remember what I just said, that every dot is a person. Okay. So what I like to do when I have a question like this is I like to count my dots for each one of these numbers here. So this means that there are 4 people that only have 1 block from home to school. 5 people walk 2 blocks. 1, 2, 3, 4. 5 people also walk 3 blocks. 1, 2, 3, 4, 5, 6, 7, 8 people walk 4 blocks. 2 people walk 5. There are none for 6. And then this lonely one person out here has to walk 7 blocks. Okay, well, then the question, remember, is asking how many, or ask the question. So now that I know each of those numbers, now I add them up. Well, I know that 8 and 2 is 10. I know that 5 and 5 is 10. And I know that 4 and 1 is 5. So if I add them together, that means that there are 25 people that answered this question. Okay, so now, make sure I'm doing the right one. It's this one. We are going to do numbers 1 through 4 in this video. We don't care about number 5. Okay, so numbers 1 and 2 says use the data set to answer the questions. Remember, a data set really is just a bank of information. Okay, so the question on number 1 says Mr. Rice's students ran a 40-yard dash in the following times in seconds. Okay, so I see decimals. Okay, so I have a 6 and 8/10, a 7 and 3/10, 7 and 1/10, and so on. Okay, notice that these are not in any particular order. Okay, this data set is given to us just out of order because that's how they ran it. Okay, so this was the first person, this was the second person, and the third person, and so on. Okay, and so what the question for number 1 is asking is how many race times are recorded? Well, that just means how many people ran the race, right? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 in the first row. and 1, 2, 3, 4, 5, 6, 7, 8 in the second row. And 8 plus 8 is 16. So 16 people ran the race. Okay. Now we're using the same information for number 2. It says use the dot plot that shows the data. So they're taking all of these numbers, and instead of being in this jumbled up, it doesn't make any sense because they're all out of order, we're putting them into order down here. So I see that my title says times in 40-yard dash. And I see that the label is times in seconds. Okay. What they're doing is they're then taking each of these numbers and they're placing a dot where it corresponds down here. Okay. So there's only one 6 8/10. So that's right here. Okay. There are two 6 9/10. So we place that here. And I see there's 3 7s, 1, 2, 3, and so on. Okay. So when you're given information like this data that is just all jumbled up, and you're going to make a dot plot, you really just say, oh, here's this number, let me put a dot. Here's this number, let me put a dot. Okay. Then this question is asking which speed occurred most often. So we're looking for the time in seconds, the speed that has the most dots. Okay. When it's in a dot plot like this, that is super easy to see, isn't it? Okay. I can see that this one has the most dots. Okay. So that would be 7 1/10 seconds. Okay. Up here, when it's all jumbled up, I can't really see that. I mean, I might be able to go through and look there and say, oh, I think it's 7.1. It's 7 1/10. But when it's on a dot plot, I can see that extremely easily. Okay. All right. So number 3 is asking about outliers. Remember, an outlier is a number that doesn't really fit with the rest of the numbers. Okay. So when I'm looking at the information from 1 and 2, I see all of these numbers are really quite close together, aren't they? Okay. There's really not anything that's like way out of place. Okay. What I mean by that is, let's say we also had a dot. We didn't have anything here or here. Continue this a little bit. Let's say we had one out here, a 7 6/10 all by itself. Okay. Do you see how everything else is pretty much in the same area over here? But this 7 6/10 is like way away from everything else, isn't it? Okay. That would be what we call the outlier, meaning it doesn't really fit with the rest of the information. So when I'm looking at this information, I would say that there's not really an outlier. Okay. And it's asking me to explain. So I would say there is no outlier because all the data are close together. Okay. And then number 4 asks me to describe any patterns in the dot plot. So look at that. Do you see a pattern? I see a pattern. Okay. Get back to it. Goodness, I hate when it does that. All right. So I see a pattern. It's increasing and then it's decreasing, isn't it? Okay. So the times, increase until, what is this, 7 1/10, and then they decrease. Okay. When you have a question like this today, don't make it over hard. Okay, some of you like to think that things are super, super hard, but they're really not. Okay, it really did just want us to describe that.